Hey guys, we are starting the second section of Chapter 9. We're actually going to start and perform a significance test for a population proportion. So in the first section, we talked about the basics of significance testing. Now we're actually going to carry one out from start to finish. So by the end of this section, you should be able to check your conditions for carrying out a test about the population proportion. You should be able to conduct a significance test about a population proportion and also construct a confidence interval to draw conclusions about a two-sided test for a population proportion. Now, confidence intervals and significance tests are both based on the sampling distribution of statistics. We learned all about that in Chapter 7. So both use probability to say what would happen if we applied the inference method many times. So earlier we talked about a basketball player who claimed to be an 80% free throw shooter. In a simple random sample of 53 free throws, he made 32. So the sample proportion, his p-hat, was 0.64, and that's much lower than what they claimed. Now, does this provide convincing evidence against this claim? We're going to be using z-scores and p-values in order to evaluate this idea. So, in order to perform a one-sample z-test for a proportion, we need to choose a simple random sample of size n from a large population that contains an unknown proportion p of successes. In order to test the hypothesis, the null hypothesis that the population proportion is equal to some proportion, we need to compute what's called a z-statistic. That's given by this formula right here. Okay, should look kind of familiar. It's similar to things we've seen in the past. Then what we're going to do is we're going to find the p-value by calculating the probability of getting a z-statistic this large or larger in the direction specified by the alternative hypothesis. So greater than for your alternative is like a right-tailed, less than is going to be a left-tailed, and then not equal to is a two-tailed. So just a little bit of remembering and a little bit of background. A significance test uses sample data to measure the strength of evidence against the null. All right. So the test compares a statistic calculated from some sample data with the value of the parameter stated by the null hypothesis. So we're comparing a statistic to the value of the parameter in the null. The values of the statistic values of the statistic that are far from the null parameter value in the direction specified by the alternative hypothesis give us evidence against the null. Okay? So a test statistic, in this example a z-statistic, measures how far a sample statistic diverges from what we would expect if the null hypothesis were in fact true. So, to do a significance test, you need to go through the four-step process. State, plan, do, and conclude. In the state step, we need to say what hypotheses do we want to test. We need to say what significance level we want to test it at, and then also define any parameters that you're going to use. So this is where you say what your h sub 0 and your h sub a are. You give your significance level. Remember, if it's not specified in the problem what significance level to use, we use 0.05. And then define the parameters. What does mu stand for here? What does, in this example, proportion? In the next step for the plan, you need to say the appropriate inference method. Okay, so what test are you going to use? Then you need to check your three conditions. Same conditions as before when we were testing for proportions. It needs to be random, normal, and independent. So, a significance test is assuming that the null is true. So we're going to use the proportion from the null to see if that's greater than or equal to 10 when multiplied by the sample size n. And then independent, remember we checked that 10% condition unless it came from an experiment, and when we just say it's independent. In the do step, as long as your conditions are met, this is when we're going to perform our calculations. So there's two calculations that need to be done. You need to compute the test statistic, which was given by that formula above this, right, from the previous slides. And so our test statistic, like I said, says how far the sample result is from the null value and in what direction on a standardized scale. So it's like a z-score kind of. And then with that test statistic, a z-statistic for proportions, we're going to find the p-value. And we talked all about p-value in the last section. And then once you have this, you're going to conclude, right? So you have to compare your p-value to your alpha, right, to your significance level. And then you have to say either you're rejecting or failing to reject the null, and then come to some conclusion about the alternative. Make sure you're always using context of the problem. Now, in a previous chapter, we used the acronym PANIC to help us remember what to do in this 4-step process. This chapter, we're going to be using the acronym PHANTOMS, P-H-A-N-T-O-M-S. So the first part is parameters and hypothesis. This is happening in the state section of the 4-step process. Say what your parameter is, say what your hypotheses are, as well as your significance level, what your alpha is. When you assess your conditions and you name the test, this happens in your plan, right? You want to make sure you assess your conditions before you even collect your data. Then you calculate your test statistic and get the p-value. That's in the do section. And then lastly, you are going to conclude, you make a decision about the null, and then you state your conclusion about your alternative. Okay? So this is just the basics. In the next video, we're going to walk through an example, and you're going to see how, step by step, we perform a significance test for proportions. So stay tuned for the next video.